Hello. Good morning. Happy what Saturday morning. It's like probably like 6 o'clock in the morning because I was bored in my bed. I mean, I woke up like about an hour ago, I guess. Then lying on my bed, but I was bored, so I just rolled out of my bed. Okay. Saturday morning, Sunday morning is not very enjoyable. Okay, it's always the weekday morning that I wanna stay in my bed longer. We always want something that we cannot possibly have, I guess. And whatever. All right. So, well, my tea is ready. So, let's go grab a cup of tea and water. All right. Okay. So we have this constant, right? Yeah. Sorry, it's a constant. Okay, it's not oscillating function. No, it's not. It is a constant. Okay, so because of the way we defined it, okay, it's not going anywhere. Okay, very slowly increasing. That's it. Okay, if we feel like it, we'll try to do some convergence test. Okay, so for now, we are just focusing on constructing this number algebraically. Okay, that's what we're focusing on. And if you have a number, okay, if you have a number, this is mathematics education. There's nothing else. Okay, so I'm not trying to make some big name to myself. No, no, it's about education. So earlier in 1900s. I don't like this 20th century blah blah. No, 1900s. Okay, it is. But we gotta translate from 20 to 1900, 20th century. We gotta translate back to 1900s anyway. So why do that shit? Inefficient. Okay. So I prefer say 1900s. Okay, instead of 20th century. Shut the fuck up. Stupid shit. So 1900s. Early 1900s, mid 1900s, they were discovering a lot of artificial atoms, and they named after Einsteinium, Mendeleev, Mendeleev, or what? Enrico Fermi, Fermium, and Curie, Madame Curie, Curium, and you have Americium, named after America. All that stuff. Okay, so Francium, named after France. We're not gonna do that with this constant. Okay, well, first of all, it's not that big of a deal, really. This constant, it's pretty okay because it's palindromic, but we're not gonna do that. We're not gonna name this after some country or city, state. We just call it skateboarders constant. Okay, because that's what it looks like. So to construct this number, well, let's go back to the basic. Yeah, it will be some kind of infinite series, some kind. Okay, so I was thinking about it when I was lying down in my bed, and I got it. Okay, the principle is this. Let's say you have some number, right? If you wanna put zero on the right side, yeah, you multiply by 10. 10 to the first, 10 to the second, right? But if you want to add 0 to the left side, how would you go about doing that? Huh? I give you 5 seconds. This is easy stuff. Yeah. You multiply by 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. Okay, that's how you add, how you can concatenate zeros before a number, left side of the number. Okay, and guess what? If you have this decimal point, right? If a number of 0 is on the right side of a number, this is a tailing end, then you can ignore that. This is ignorable. Okay? And then you have some number on the left side of this decimal point. And guess what? You add 0 to the left side on the, it's like that tailing 0, trailing 0, but leading 0, heading 0. Yeah, it's ignorable. Okay, so there's some symmetry there. Okay, depending on whether it's heading 0 left of this decimal point, or trailing 0, leading 0, or trailing 0 to the right side of this decimal point. Okay, yeah, they're both ignorable. Okay, so there's some symmetry. Okay, all right, we're just covering the basics. Okay, so now it's getting easier and easier. All right, as you can see, we found this pattern. Okay, this is our constant. Okay, now we need to construct this in terms of infinite series. Okay, so we may have to redefine that sequence over there, or just tweak it a little bit. Okay, or not. Well, we don't want to quite redefine that sequence that we came up with. Okay, so probably we're gonna do this 1 0, and you have 1 2 1 0, and 1 2 3 2 1 0. Okay, so yeah, we're gonna have to do that. Okay, that's A1, A2, A3. Now C is equal to A1 multiplied by 10 to the nah, we have to be very careful, because we cannot treat 1 0 as 0.010 as 0.01. We have to preserve this 0. Okay, so we have to be very careful here. We have to be very, very careful. Okay, because this 0, we cannot ignore it. Okay, so it is a little bit tricky. We may have to redefine that sequence after all. Okay, I try to stick with it, but it turns out that maybe we can. Yeah, we can. Because yeah, we can. 1 2 1 2 3, 10 to the negative third. Okay, plus so 1 2 1 0, right? 1 2 3 4 times 1, 2, 3. A2 times 10 to the minus 3 plus 4. Okay. Plus, can you see this? Can you read this? A3, I write it bigger. Okay. 10 to the minus 3. Yeah, we are looking, finally recognizing the pattern here. 1, 2, 3, 4, 5, 6. Okay? And it's this, okay? So, plus 8 plus dot 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 plus a to the nth times 10 to the minus, it's like this. 1 plus 2 plus 4 plus 6 plus blah 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 plus yeah, 2n. Okay. Why? Because we are doing palindrome, okay? Palindrome. So we will start from 0, then you have 0, 1, 0, and then you have 0, 1, 2, 1, 0. So the length of a palindrome, it jumps from 1, 3, 5, right? So it's a geometry increase. It's increment by 2, okay? And in our sequence, it goes like this: 1, 1, 0, 1, 2, 1, 0, because the leading 0, we get rid of that, okay? So it comes like 1, 2, 4. Let's do one more. 1, 2, 3, 2, 1, 0, okay? How many would that? 6, okay? Yeah, it's like nth, yeah, it'll be 2 times n, okay? 1, 2, 3, something like that, okay? So, okay? And what is that? Well, we have handed in the formula for this, so, what formula was that? Well, it's probably you add this to probably something like this: 1 plus 2n divided by 2 multiplied by n. It probably is something like that, okay? So let's see if that formula is correct. So we don't start from 0, okay? We actually start from 1, 0. When n equals to 1, yeah, I guess we're missing something. Okay, so you add this How does this? Because it's kind of like symmetric, is it not? Maybe not. Oh boy. Well, how about this? We'll leave out one, okay? Because if you add 2 plus 4 plus 6 plus 8, they're symmetric, okay? You add first and last like this, and you add this, okay? So in this arithmetic series, okay? It's not geometric series, but arithmetic series because what is 8? It's the an. An is equal an is equal to 2 times n, right? So it's a linear, okay? So increment by 2. It's not like, okay, so in arithmetic series, it's always symmetric like that. So 2 plus 8 is equal to 4 plus 6, okay? You can always add, so 2, the very first one, plus the very last one, okay? And how many of them are there? Yeah, n divided by 2, okay? So yeah, that's the formula right there. So it's equal to what, 2n, I mean n squared plus n plus 1, okay? So that, I think that's the formula here. When n is equal to 1, yeah, 3, okay? N is equal to 2, 4, 2, 1, 7. When n is equal to 3, 9, 3, 1, 13. We got it, okay? So yeah, that will be the formula. Okay? Now all we gotta do is just write down, okay? So because we have our formula, ladies and gentlemen, congratulations, okay? We finally got it. And it's not cakewalk, okay? I mean, conceptually it's easy, right? Palindrome. Palindromic infinite number. It's not infinite, it's irrational, this number that goes on and on and on and on, okay? But it has recognizable pattern, yeah. Enlarging palindrome, okay? Palindrome pyramid, palindrome triangle, okay? We're just connecting from here, 0, 1, 0. We're just connecting all together, okay? And make it, that's how we construct a number, okay? And without allowing, and guess what? Okay, 0, 1, 0, 1, 2, 1, 0, okay? All right. So yeah, it's, this triangle isn't exactly palindrome because we don't have leading 0, okay? But yeah, we're just solving them. I'm gonna take a picture of this and I'll zoom that in for you. I'm sorry, I forgot all the time. Forgot to zoom it in for you, okay? But it's very easy stuff, and when I'm writing all this, I'm reading it to you, so it shouldn't be too difficult to follow, even though I write it very small. But okay, so I zoomed that in for you. I'm sorry, I forgot